Good evening, participants. Am I audible?
Yes, ma'am.
Yes, ma'am. Yeah. Good evening. Welcome you all for the third day of the ATAL sponsored 6-day online faculty development program on foundations and applications of data science. Today we have with us Dr. Priyadarshini, who's the senior professor in the School of Computer Science and Engineering at VIT Chennai. So as the speaker of our day for the two sessions, session 5 and 6. She will be handling the session 5, the unsupervised learning, covering clustering and dimensionality reduction, and session 6, the natural language processing basics. It is my pleasure to introduce Dr. Priyadarshini. She has earned her PhD in Information and Communication from Anna University in the year 2014, and she holds both her BE and MA degrees in Computer Science and Engineering from Anna University. With over 16 years of academic and research experience in MIT and VIT, she has made a remarkable contribution to both teaching and research. At VIT, she has taken the key leadership roles. Her technical expertise spans across artificial intelligence, machine learning, big data analytics, image processing, soft computing, and multimedia systems. Dr. Priyadarshini has also successfully guided 5 PhD scholars in areas such as computational intelligence, big data, machine learning, and medical image processing. She has published around more than 50 research articles in reputed journals and conferences, and has also contributed to the book chapters and authored works in artificial intelligence and emerging technologies. She has been a resource person, chair, and invited speaker at several international and national conferences, workshops, and FDPs. Her invited lectures covers the AI applications across the diverse domains, including law, healthcare, and structural analysis. We are honored to welcome Dr. Priyadarshini, a distinguished academician, researcher, and mentor whose contribution continues to inspire students and scholars. Welcome you, ma'am, Dr. Priyadarshini, ma'am. Yeah,
thank you,
over to you. Yeah, over to you, ma'am. You can continue. Thank you.
Okay. So, good evening, all.
Good evening.
Good evening, ma'am.
Okay.
Good evening,
Other
ma'am.
than organizers, I think we can have others also. The ears little bit opened.
Good evening, ma'am.
Thank you. Okay, so we'll go directly with our class. Let me share my slide. You're able to see my slide?
Yes, ma'am. Yes, ma'am.
Can you see the slides changing also?
Yes,
Ma'am,
ma'am.
it's not in the presentation view.
It is in the presentation view for me. How about others?
No, ma'am.
Okay, then let me reshare. How about now?
Yes, ma'am. Yeah.
Yeah, perfect.
Yes,
Okay.
ma'am. Yeah, perfect.
So can you see the slides changing also?
Yes,
Yes,
ma'am. Yes,
ma'am.
ma'am.
Yes.
Yes, yes.
Thank you all. So with this, we are not going to sleep. We are going to wake up. And those who are really listening, I take the liberty to ask you to keep your videos on also. So your mom has told I can go with the problem solving since you're listening in the laptop or system. I think we can work with simple Excels. Is it fine for all? You can give your messages in chat.
Yes, ma'am. Yes, ma'am.
Okay.
Yes, ma'am.
Starting with clustering. So before going on with clustering, can I know what were your previous day topics? Anybody can summarize? Just for
It's
me to
all
know
about
what were the
supervised
things.
learning.
Oh, you're done with supervised learning?
Yes, ma'am. Regression.
Okay. Classification, regression, both are done.
Yes, ma'am.
Okay. So we'll then move on with unsupervised learning. So in unsupervised learning, clustering is what is the main. So clustering, when we say, or to put this way, when we say unsupervised learning, fine. Okay, what is the main thing of supervised learning? The key point of supervised learning?
It's all about trained data sets, ma'am.
Okay, other than that, just one keyword.
Labels.
Ma'am, it
Exactly.
will predict the output based on the
Will
input,
use
ma'am. Labeled
labeled
input.
data.
Exactly. You will be using labeled data. Supervised learning is nothing but like how we had learned to ride a bicycle. Fine, for sure, our parents would have guided us, our sibling would have guided us. You would have taken the help from somebody, and then only you would have known how to move a bicycle. You would have known how to pedal a bicycle, and then slowly somebody would have hold you for 1 day or 2 days. Then they would have left you, hold you from the behind, and then slowly they would have left you. Fine. So step by step process is being done in supervised learning, and the main thing is data labels will be given. Now a step ahead of that is unsupervised learning, where we will not be given the data labels, only data is being given, and you will be trying to identify the similarity or the patterns. Fine, so that is what is clustering. So clustering, if you see, we are just going to group them. Fine, distinct groups. It can be distinct groups, or it can be even overlapped groups based upon the technique whichever you use, or based upon the data set. So basically, we are going to group them into subsets or clusters, and we are going to use similar characteristics. So how do you choose your friend? Whom get to be your friend?
Based on the mindset, ma'am. Frequency.
Okay, so either mindset or wavelength, or sometimes the moment we see them, we like them, we start talking to them. Fine. So basically, it is about some similarity we find with them, and that is how we tend to make friends. The same thing is what is clustering. You're going to find a pattern, and you're going to group them together. Fine. So the main aim of clustering, as I told you, is only grouping. Only thing is you will be having unlabeled data. So the data are not going to be labeled. You're just going to be, I can put this way, you're just going to be let into a shopping mall without any constraints. It's about you going and choosing your dress of your likings. Fine. So that is what is clustering. And then the method, basically, when we say similarity measures, fine, or the persons with similar pattern. So when I say similar pattern, fine, so whomever is nearer to me, only them we try to get attracted. So for that, we go with a distance metric. Fine. So some methods go with the distance metric, some go with the similarity appearance. And then the measures, as I told you. So distance metric, when we go, we can go with cosine similarity, Euclidean distance. Basically, almost all the techniques go with Euclidean distance, or sometimes we go with the Manhattan distance. Fine. So group, when we say, we go with the cluster ID. So we have two different types of clustering, hard clustering and soft clustering. Hard clustering is nothing but it is very strict clustering. That is, it will be assigned to only one group. Whereas soft clustering, you can see the likelihood. So 90 percentage, we can say that today there will be a rain, something like that. So it may rain or it may not rain. So it depends upon the likelihood. And hard clustering, because we are assigning it to only one group, we simply put it rule based and it is easier to predict. Whereas here, because we are just giving a likelihood, it can be placed in multiple groups. Right? So in this hard clustering, it cannot represent ambiguity. Here it can do ambiguity also, it can do represent. Now these are the techniques which we have in clustering. We have centroid based, we have density based, connectivity based, and distribution based. So for each of them, I have given one example which we are going to see. So centroid based, we are going to go with k-means. Other than k-means, we have something called as a k-mode, right? And we also have k-medoid. So k-mode is nothing but it is going to be like for the reviews or for the rankings when you have a very limited data set. Fine. So reviews, what will be your value for reviews? What will be the scale for the reviews? You do fill feedbacks, right? For the hospitals, for the hotels. What will be the feedback limits?
One to 10 in a scale?
Yes, either 1 to 10 or 1 to 5,
1 to
or
5,
even some of them starts, if it is a marks for the students, we start with 0 to 5, right? So when those kinds of limited data sets are there, then we go with K mode. Fine. So mode is nothing but frequently appearing data set. Then we have k-medoid, which is similar to k-means. So basically, centroid-based systems will be organizing the data points around a central protocol or around the centroids. Fine. The second type is density-based. So as the name suggests, fine. So based upon the density, how dense the volume of the data is going to be, based upon that we'll be dividing them or clustering them. So example for density based, we have DB scan, and then connectivity based, we have agglomerative, or it is called as a hierarchical clustering. So in k-means, actually, if you see, it cannot address the outliers. Any of the centroid based technique cannot address the outliers. But if you see density based clusterings, it can go and address the outliers. Coming on with connectivity based, we need not say how many clusters are needed. So unlike centroid based, you need to give the k value. K value stands for number of clusters. Whereas connectivity based is not like that. It is simply represented using tree based structures where a hierarchy will be given. Right? And then distribution based, this is what is like probability based distribution. So Gaussian mixture model. So entirely we'll be having 4 different types of clustering techniques. So I repeat, centroid based clustering, you have density based clustering, connectivity based clustering, distribution based clustering. So centroid based clustering will be going with k-means, density based we'll go with DB scan, connectivity based agglomerative, and distribution based we'll see the Gaussian mixture models. So first, centroid based clustering, k-means. So as I told you, general clusterings, it is going to identify the pattern, and here it is going to take an unlabeled data set and it is going to identify the patterns based upon the distance metric. So as I told you, distance metric based, that is based upon the proximity, and the metric which we'll be using is the Euclidean distance. This is the algorithm by which we'll be going on. So K represents the number of clusters which we'll be going on with. So when we say we are going to cluster them, which distance do we tend to take? The points with the least distance value or the points
Excuse
with...
me, ma'am.
Yes,
Uma
ma'am.
Mageshwari, madam. Yeah, Uma Mageshwari, madam, can you mute your from your end? Uma Mageshwari. Yeah, yes, ma'am, please.
So when we go with the distance metric and when we say that we are going to cluster the similar data together, and when we are applying a distance metric, whom do we choose? That is the data points who are nearer to me, I'll choose as a group, or the data points which are farther to me, I'll be taking as a group. It's a question mark which you're supposed to answer. Which group of data will we tend to take? The data which is nearer to me or the data which is farther to me? You want me to go with the chart? You can put it in the chat. Which data will you tend to take? When you cluster them, do you take the data which is nearer or do you take the data which is farther? Okay. So we'll be taking the data which are nearer. Fine. So you'll be taking the nearest centroid and you'll be forming the clusters. Fine. So initially we'll be going on with random selection of centroids. Fine. So K stands for number of clusters. So say suppose I am giving K equal to 3. Then of the data set, fine, we'll be taking some randomly 3 values and we'll be starting the calculation. So for these 3 cluster heads, we'll be calculating the distance metric with the entire data set, and then we'll be recalculating the centroid based upon the ones which are nearest. So anyway, I have a problem. You can just see. So these are my data points. Fine. So I have 1, 2, 3, 4, 5, 6, 7, 8 data points I'm having. Now you can see here I have 3 clusters. Fine. And these are my initial cluster heads I'm taking. Now what I'm supposed to do is I'm going to take the first cluster head. Fine. And I'm going to identify the distance with all of my 8 values. So I'll be using the Euclidean distance. Hope you all know the Euclidean distance formula. Fine. So I'll be finding out for all of the 8. And then I'll be taking the second distance 5, 8. And again I'll be finding it with all of the 8. Then I take 1, 2, find the distance with all of the 8 values. Am I clear?
Yes, ma'am.
Yeah. So since you are working with system, I feel like you can go with finding the values of 2, 10 with all the 8 points. Is it fine? Or do you want me to project directly? So do you want to work out? You can put it in chat. Otherwise, we can directly go with the projection of PPT. I'm okay with it. Anybody? Do you want to try it in Excel?
Yes, ma'am. You can make it as with Excel. Let it be interactive.
Okay, so if you want, I can give you the data points. So these are the data points. I've put it into the chat. You can take them. I don't want you to do the entire sum. I can just project it over here. This is the formula which you will be using. So square root of, because it's an equilibrium distance, fine. You know x1 minus x2 the whole square plus y1 minus y2 the whole square. So that is what is being used. Just for your reference, I'm pasting this also for you. My initial clusters. So to make your work simple, you can place it in the same cells like B2, and B2 will be 2 and B16 will be this initial clusters point. So if you want, you can work down just for on at least for one or two values. Or if you have a paper and pen, you can work out and give me the answer for at least one or two values. So 2, 10 with 2, 10, what will be the answer? Distance metric of 2, 10 with 2, 10. You can put it in chat also. What is the distance between 2, 10 and 2, 10? Is it that hard? 0. Yes, it is 0. What about 2, 10 with 2, 5?
Five.
Yeah. Okay, good. Somebody else. What about 2, 10 with 8, 4?
Six root two.
Okay. So we'll
2.
go. Okay. So if you see, this will be my answer for 2, 10 with all my values. Fine. Similarly, my next cluster is 5, 8. So 5, 8 with all the data set, I'm finding the distance value and find distance to C2 is this column. And finally, C3, that is 1, 2, I'm taking and I'm finding the distance value. Fine. So these are the distance metrics, whichever we have calculated with the random cluster heads. Fine. Now, how do we group them? You told we are going to take the nearest distance. So for A1, the data set A1, to which cluster it is nearby? Is it with C1 or is it with C2 or is it with C3? Towards which cluster head it is nearer?
C1.
Yes, right? Because of these three values, I am supposed to take the minimum value. You told whoever is nearer to me is going to have the nearest distance, or that is nothing but the minimum distance. So I am taking the minimum distance, that is 0.00, and that belongs to cluster 1. Fine. What about data set A2? So answers are on the screen.
Cluster
So
3.
yes, you are only supposed to find the minimum value, and that also I have highlighted. Okay, so 3.16. Similarly, A3, I can see 2. Fine, B1, 2, cluster 2, B2, cluster 2. So for the entire data set, I have marked the clusters to which it belongs to. Now, I told you this is a k-means, which means I am going to find the centroid or average. How do I find the centroid or average? For cluster 1, I have the point only 2, 10. So what is going to be my center or centroid? I have only 1 point. So what will be the center? It will be the same. 2, 10 will be the first cluster head. Now what about the second cluster head? I have A3, I have B1, I have B2, I have B3, and I have C2. So I need to find the average of all of them. What is the average of all of them? I need to find the average of all of these. What is the average of all of these? Average of these values?
So 6.
Okay.
3
6.
points nearest to 4, ma'am. 3 points something. 3.8 or something like that.
6. It should be 6, right? 6 and 6 only.
6 only.
Yes. 6, 6 is the average for cluster 2. Now, cluster 3, we have 2 points, that is A2 and C1. 1, 2 and 2, 5. Finding the average of them will be 1 plus 2 by 2 and 5 plus 2 by 2. 1.5 and 3.5. Am I right?
1.5 and 3.
Hope all of you are
Yes,
following
ma'am.
me. So my new clusters or my new centroids will be 2, 10, fine, 6, 6, and 1.5, 3.5. I'll stop here and I want you people to know whether you are with me. We have 111 participants. How many of you are with me? You can raise your hands. How many of you understood whichever I told up to whatever we have done till now? Okay. Yeah, good. So, shall we continue then?
Yes, ma'am.
Okay. So now with these new centers, again for the entire data set, I'm going to find the distance metric. I'm going to find the minimum value and I'm going to find the new cluster to which it belongs to. Fine. So here actually whatever I have fixed, fine. This is going to be my old cluster. Fine. That is this column. And whatever I am going to find with my new data set, sorry, new cluster values, new centroids, that becomes my current cluster. Fine. Now we need to see whether both of them are the same. Are both the clusters the same? You can see the values also here. My current cluster is 1. My old cluster was 1. No problem. Current cluster is 3. My old cluster was 3. Current cluster was 2 and my old cluster, sorry, current cluster is 2 and my old cluster was 2. Again 2, 2, no problem. 3, 3, no problem. So if I see my last value alone with my initial clusters, fine, that is with my clusters 2, 10, 5, 8 and 1, 2, I had seen that the last point 4, 9 belongs to cluster 2. But when I have revamped my new clusters, I can see that 4, 9 is moved from 2 to 1, which means there is a change in my cluster. Fine. So I need to repeat the process again. Unless and until the clusters are going to be the same, I need to repeat the process. Fine. So how do I repeat the process? How do I repeat the process? I need to go find the new centroids. How do I find the new centroids? Now with this data that is being presented to you, give me the new centroids. Give me the new 3 centroid values. How do I calculate? Average of 1 and 1. That is A1 and C2. What is the average of A1 and C2? We are going to find the average of cluster 1s. So what is the average of the cluster 1 values? What is average? That becomes my new
3 and
centroid.
3 and 9.5.
3
3 and
9.5.
9.5. Okay. What about cluster 2? So cluster 2 are these values. So 8 plus 5 plus 7 plus 6 by 4. 4 plus 8 plus 5 plus 4 by 4.
6.5 and
Okay.
5.25.
5.25. Okay. And then my cluster 3 remaining A2 and C1. It is going to be the same because cluster 3, I think there is no variation. So it is going to be the same as 1.5 and 3.5. So you can see over here, fine, my new clusters or my new cluster heads I've got. Now again, I'm going to continue the same step, find out the clusters, and I'm going to see whether there is going to be any change. So the old cluster will be nothing but the previous iteration. I'm not taking the first iteration. Old cluster will be the previous iteration's current cluster. Fine. So now here again, upon doing this, you can see that again there is a change from B1, that is data set B1 from 1. Fine. Initially it was in 2, it has moved to cluster 1, which means again I need to go on with a new data set. Fine. So if you see here, I have found the new data set and again I'm comparing the clusters and wow. So here we have got the same clusters, which means I can stop over here. And for the data set, whatever we have over here, fine, the 3 clusters or we have told that k is equal to 3, right? So the 10 data points what we wanted them to be put into 3 clusters and the cluster head or the cluster centroids are these 3 pairs. Fine. So diagrammatic explanation you can see over here. I have printed all the points over here. Fine. And the clusters you can see over here. So I have a cluster over here. I mean cluster head over here, cluster head over here, and cluster head over here. And these are my 3 clusters which is being formed. Fine. So this is K means. Am I clear?
Yes, ma'am.
Right. So I just have another interactive tool where I can show you the Just a minute. So this is just for an interactive tool. I have given 3 clusters over here. Fine. This iterations I can reduce to just 40. Fine. I have 2 columns, x-axis and y-axis. I'm just giving start k-means. So, okay. So these are the data sets. Whatever we had done is only 8 data set. Here I have taken a larger data set. You can see how the iteration goes on and how the cluster changes. And here the distance metric, how it changes. Fine. With 7 steps, the clusters are being formed. Okay, so I have 3 clusters and these are my centroids. So when I click upon the points, you can see what are the points also. So the new coordinates, that is the centroids are going to be this. So if you want, I can just show you the previous step, whether there are changes or not. So you can see here, fine. So whatever we had done. So the distance metric and the clusters to which it belongs to are being printed. Okay. So this is k-means. We'll go back to our PPT. So evaluation technique, if we see, sum of squared error and silhouette score is what is the evaluation technique. To get the optimal k value, we can go with the silhouette score. It is a histogram based technique. Right? Applications, we can go for data segmentation, image compression, anomaly detection. So based upon the distance metric, you will be able to do the data segmentation or image compression very well. So coming on with the pros and cons, it is simple because you have just learned and you know how to do it. It is very simple. Fine. Only thing is, it is very much sensitive to outliers. The current techniques for k-means is k-means plus plus, we call it. Fine. So how does it takes the centroids is not randomly. It takes the 2 farthest points, or the one with a minimum value and one with the maximum value it takes, and it takes the centroid as it is. Between if a cluster is there, fine. So for a cluster, what is the minimum point and what is the maximum point, and between them the centroid will be taken. The centroids are not taken randomly like how we had done. Fine. So k-means plus plus is the one which is been currently active now. Am I clear? Shall we move on with the next topic?
Yes, ma'am.
Okay.
Please.
Yes, ma'am.
So, yeah, thank you. So density based clustering, as I told before, density based clustering is for a voluminous data which doesn't have any shape or anything. Even if there are outliers, density based clustering can find them out and it puts them as a noise. Fine. So you can see here as dense regions, it will be able to identify. Fine. So as I told you, arbitrary shape. That is, it doesn't take any shapes into account. It can take anything and it can find out. Especially, it will be able to identify the noise and the outliers. Fine. So the steps, you are going to identify the core points. You're going to form the clusters. You're going to identify the border points, and then you're going to eliminate the noise points. Fine. So coming on again with an example. So I have around 12 data set, 12 data points in my data set, and I'm asking clusters with minimum 4 points. and epsilon is 1.9. When I say epsilon, it is nothing but it is a kind of radius. Fine. So I'm going to draw a circle, fine, with whichever is going to be within the distance metric of 1.9. That is what is epsilon saying. So basically, I'm going to find the distance metric again here using Euclidean distance, and whichever distance metric is less than this 1.9, only them I'm going to consider. Again, there is a constraint of I need to take only, I can call the data set as a cluster only if they have the minimum of 4 points. Okay, so this is very big data set. So you can see here, my all my 12 points I have taken, and I am finding the distance metric. Fine. So now coming on with P1. Fine. You're going to take the first column, or to literally say the second column, P1. We are talking about P1. So P1, with which are the points it is having the minimum distance. That is our constraint. You know that it should be less than 1.9. Fine. So P1 column, whichever values are less than 1.9. Which are the points with which its distance is less than 1.9?
1.4, P2 and P10.
Exactly. So we have P2 and P10 to be less than 1.9. Similarly, for P2, I have P1, P3, and P11. And it goes on. For P3, I have P2 and P4. So you can see the highlighted points I have. Fine. So now I am grouping all of them together. Fine. For P1, I have P2 and P10. Whatever I have written over here. Fine. Whatever we have highlighted over here, P2 and P10. For P2, if you see, I have P1, P3 and P11. We'll check P1, P3 and P11. Am I clear? So P3, if you see, we have P2 and P4, right? So P3, P2 and P4 we have. Fine. Similarly, I'm writing it for all the points. Now it is being asked my minimum point should be, or minimum cluster should be 4, which is inclusive of the point whichever you are going to take. That's why here neighbor count, you can see I have given 3. That is P2, P10 and P1 inclusive. Fine. Similarly here I have P1, P3, P11 and P2. That's why I have given the count 4. So now minimum points, it should be 4. Fine. So whichever is 4, that I am going to write it as a core point. Fine. So here you can see whichever is 4. That is, here I have 4, here greater than 4, here I have 4. Right? So which are the points?
Ma'am, will you please explain once again the neighbor count, ma'am?
Yes. Let me discard. So this is my data set given. Fine. Since this is a clustering technique, here it is being told your clusters is valid if it is going to have minimum 4 points. Fine. And my radius is being given to be 1.9. Radius here is nothing but the distance metric. So we are calculating the Euclidean distance and we have put it over here. So whichever is less than 1.9, those distance metric we are going to take. So here I have 1.41 for P1. I have P2's value to be 1.41 and then I have P10's value to be 1.41. For P2 I have P1 value less than 1.9, P3 less than 1.9 and P11 less than 1.9. For P3 I have P2 less than 1.9 and then P4 also less than 1.9. So similarly, I'm writing it for my entire data set. Since our count is told minimum 4 points belongs to one cluster, this minimum 4 points we are going to take. So how are we going to take? The neighbors within the epsilon we have, and that is concerned with my original point. So P2, P10, P1 inclusive. That is why we take the neighbor count to be 3. Similarly, here I have P1, P3, P11 along with P2. Fine. That is why the count is given 4. Next, P2, P4 along with P3. We are taking P3 and for P3 only we are taking the distance metric, right? So that point is also inclusive. Self point is inclusive. So we have 3. For P4, P3, P5 along with P4. So I have 3. Am I clear?
3. Yes, ma'am.
Yes.
Thank you, ma'am.
So now if you take P5, I have P4, P6, P7, P8 and P5. So I have the count of 5. Fine. Now they have asked, we need to take a minimum count of 4. So whichever is having 4 and greater than 4, that belongs to one group. Fine. Or I mean that belongs to a cluster. So you can see here, I have this, change the color. I have 4 over here, I have 5 over here, and I have 4 over here. So these 3 points are only going to be my core points. Fine, because only they are satisfying this rule of minimum 4 points. So only P2, P5 and P11 become my core points. So the rest of them, we are going to keep them as noise. Fine, for now. Now, I cannot simply say only P2, P5 and P11 to be core and the rest of all of them to be noise. Fine. So that is why they came up with another point saying, calling it as border points. So whatever points are there along with my core point. Fine. So when I say these are the core point and when they become as a cluster, I cannot say the other points which are along with the cluster to be a noise, right? So whichever points are there along with my core points, they become the border points. Fine. So now tell me, I have P2, P4, P5 and P11 to be my core points. Along with P2, what are the other points I have? Along with P2, I have told P2 is a core point. When did I say
P1 and
P2 as a
P3?
core point? Exactly. So when do we say P2 as a core point? Because along with P2, it has 3 more neighbors within the radius. So who are those neighbors?
P1, P3, P11.
Exactly. P1, P3 and P11. So I am going to mark all of them as border point if they are not a core point. So P1, is it a border point or a core point?
Border
Border
point.
point, ma'am.
P1, exactly. P1 becomes a border point. P3 becomes a border point. What about P11?
It's also border point.
No, P11 is already on a core.
Core. Yeah, core.
Yeah, so we cannot change the core point. So P11 becomes the core. I should say P11 is retained as a core. So I have changed P1 and P3 to be border. Now coming on with P5. So along with P5, I have P4, P6, P7 and P8. So P4 also I'm changing it to border. P6 also I'm changing it to border. P7 also I'm changing it to border. P8 also I'm changing it to border. Similarly, for P11, P2, already we have changed to border.
P2.
P10, yes, we have already changed it to border. P12, we are changing it to border now. Fine. So
P2 is core, ma'am.
P2 core. P2 is core. Sorry, ma'am. Thank you. So P2 is core. Fine. So P12 we have changed to border. So do you see any point that has been retained as a noise? You'll be able to see that P9 will be retained as a noise. Am I clear?
Yes, ma'am.
Okay. So this is the graph of whatever we had seen. The same points taken, and you can see here P9 is the only noise. Fine. This is Python code and we have run it over here. So you can see these are the border points. P11 and P2 are the core points. Fine. P5 is also a core point, whereas these are the border points. Fine. Am I clear?
Yes, ma'am.
Okay. So we'll go here, an interactive section. We scan. So here epsilon is 0.5. It is very less. We'll go with 1.5. Minimum points, I'm taking 4. So it goes for 16 iterations. These are my data set. Okay, I'm going to give a play. So I can see how there is a change. And you can see that whether it is inside epsilon or not, that also is there down going on. 16 iterations done. So you can see here the distance metric, minimum points 4. So the point P12 is a noise here. Fine, because it has less than 2 neighbors. If you want, I can show you the previous iteration. So here you can see we had 3 points. Fine. Then converting it into border points. Fine. Am I clear up to now?
Yes, ma'am.
Okay. We'll wake somebody up. So how many of you are with me? Raise your hands. 3, 8, 9. Okay. So how many of you can take a quiz now for DB scan and K-means? How many of you are ready to take a quiz? We'll see whether hands are going to go down or increase. It is decreasing. Okay. So, okay, no problem. DB scan. Thank you. Okay, sir. Thank you. We'll go back. Anybody wants break? 30 seconds
Ma'am,
break.
I want to ask one thing, ma'am.
Yes, sir.
Yes, ma'am, that mean the point which you have taken as a silent radius of the circle, depending on the circle, all the clusters will be rearranged again.
Depending on the circle.
Yes, length of the circle, radius of the circle, that the grouping will be regrouped again. Nah?
Yes, sir. But depending upon the radius of the circle, it will be grouped together. See here, actually in my PPT, it is as 2 distinct clusters. Fine. But if you are going to work manually, there will be one more cluster. I meant you can also have like this. It will be like this.
Overlapping cluster.
Yes. So it can be an overlapping clusters.
And there will be some in this the three circles which you draw in this case, there will be three noise points.
Yes, 3 points. I can show you one more. Just give me a minute. So you can see over here.
Yeah, this one.
It can be an overlapping clusters. Okay, sir.
Okay. Yeah. Okay, ma'am.
Thank you. So we'll go with the next one, connectivity based. So connectivity based, when we go with, we'll go with the hierarchical clustering. As I told you before, hierarchical clustering is nothing but tree based structure. Okay. You cannot or you need not give that these are my determined number of clusters for hierarchical based clustering. It is layer wise approach, or I can say it is a hierarchy based approach. And the representation is, we call it as a dendrogram. It is a tree like structure. Okay. You can have multiple levels. Parallelly, we can have multiple levels. Okay. So we have two different types in this hierarchical based, agglomerative and divisive. We are going to see with agglomerative. So agglomerative, it is going to start with each point, okay, and cluster them. And finally, it will be, okay, it will merge basically the closest clusters. Divisive, it is going to start with one cluster and it is going to split it. So basically they are bottom up and top down. So divisive will be like it first starts with one entire cluster, then it keeps breaking the data set, fine, based upon the distance metric. Agglomerative, it will take each of the point and it will start clubbing and make them as a cluster. Fine. So this is how your agglomerative will be going on. For agglomerative itself, we have single, complete, and average. I'll tell you what is the difference. So single will be taking the closest distance, and then complete will be taking the farthest distance. Average, as the name suggests, will be taking the average. Now the point where the kids, that is the students, will be getting confused is, may it be single, complete, or average linkage. The first point what you are supposed to do is, after finding the distance metric, is you should always take it the minimum distance. Fine. After taking the minimum distance, while clubbing them or while pairing them only, you will be applying the either the single or the complete or the average linkage. So where it lies, where the difference lies, I'll tell you now. So single linkage, this is my data set I have taken 18, 22, 25, 27 and 42, 43. Fine. Now I have found the proximity matrix, that is distance metric I have found. The first point is calculating the Euclidean distance and filling up the table. Second is I need to find the minimum distance. So other than the diagonal values, what is the minimum distance I have over here? Everybody have gone for a break?
One.
Yeah, at least one
Two,
soul. One.
two, ma'am. One.
Two
Sorry.
minimum value. So one.
Okay.
Okay, so I'm taking, you see, basically it is enough. I just have one half of the table. If you can relate my upper half of the table, it is enough for you to go with only one half of the table. But for better understanding, I have given the upper half also. Fine. So now I'm going to take the minimum value, that is 1. 1 is to be paired for 43 and 42. Fine. So this basic step, that is finding the minimum distance, is the same for all the agglomerative techniques. Fine. Now we are with the single linkage, which means after pairing 42 and 43, we need to write the values related with them. Now, writing these values related to with them for single linkage, I'll be taking the minimum distance. Fine. That is of 42 and 43, whichever is the minimum distance, that will be filled in the table. So for 18, 22, 25 and 27, we'll be writing the same values. So you can see here 0, 4, 7, 9, I have written. Similarly for 22, I have written 4, 0, 3, 5, retained. 25, I have retained 7, 3, 0, 2, I have retained. 27 also, I have taken 9, 5, 2, 0, retained. Now, my aim is to combine 42 and 43. So when I'm going to combine or pair up 42 and 43, I'm going to take the minimum value of them. So what are the minimum values of each and every row of 42 and 43? So I'm going to take the first for 18 of 24 and 25. What is the minimum value?
24.
So I'm writing 24 over here. Of 20 and 21, 20 is the minimum value. Fine. Of 17 and 18, 17 is the minimum value. Of 15 and 16, 15 is the minimum value. Fine. So it is not always that for now we have taken 42 as it is, but it is not always going to be the same. Fine. Not always the same row of details will be the less values or the minimum values. Fine. So now we have combined 42 and 43. Now tell me which is the next minimum value here?
It's 2.
Yeah.
0.
0 illa, not the
Oh, yes.
diagonal values. We are not going to take the
2.
diagonal values. We are
Oh.
only taking the other values. Diagonals are for the self. Fine, we cannot cluster 18 and 18 itself. We are trying to cluster the other pairs. So other than the diagonal values, whatever is the minimum value. So 2 is my minimum value, which is nothing but a pair of 25 and 27. Now give me the
27.
values of 25 and 27 combined together.
The row will be, ma'am, 7, 3, 0 and 0.
Exactly.
25 plus 27.
Super, sir.
And the
So,
column will be,
sir, the column you can just retain, no problem.
yeah.
So, 25 and 27, basically 7, 3 will be retained. Fine. So, if you see over here, I need to go with the next minimum value. Fine. So, what is the next minimum value I have here other than my diagonals?
3.
3.
Exactly. So, 25, 27, and which one I'm going to pair up with? 22.
2.
Right? So you can see the values. And one more thing I wanted to say here is, you can see here, I have given everywhere at distance. Fine. So 42 and 43, we combined them or we paired them when the minimum distance is 1. Fine. So when we are drawing a graph, we have to see to that at the axis 1. Fine. Anyway, I'll show you. At the y-axis, when my y-axis is 1, I'll be combining 42 and 43. And when my y-axis is 2, I'll be combining 25 and 27. Fine. When my y-axis is 3, I'll be combining 25, 27 with 22. Am I clear?
Yes, ma'am.
Yes, ma'am.
Okay. So I have done now up to one cluster we have taken it out. So that is what is agglomerative. It will take individual points, fine, and then it will club them together. Fine. So now we have taken the first cluster was 42 and 43 at the distance 1. Am I right? Next, we did 25 and 27 at the distance 2. Right? Next, we combined 25, 27 with the 22 at the distance 3.
3.
Yes? Fine. So then the remaining with 18 at the distance 4. And the final cluster, which was making them all single, was at 15. Fine. So this is called as a dendrogram. You need to see that distance is going to be on my y-axis and on my x-axis are going to be my data points. Am I clear? So this is
Yes, ma'am.
single linkage. Okay. Is it okay if I'm going to explain in the same, the complete linkage?
One thing,
Yes,
ma'am.
sir.
One thing,
Yes,
ma'am.
sir.
Excuse me, ma'am. In the last two methods, we are getting clusters with points. How many clusters we have, and in this one, we are getting a single cluster, and this will be denoted by this graph which you have shown on the last page.
Yes, sir. Okay, I'll go again here.
This one is
Yes,
also
yes.
a clustering method, or what type of
Yes,
clustering
sir.
we have in this?
So K means what we saw comes under centroid based clustering. Fine. DB scan is density based. Now what we are seeing is connectivity based.
This is your first, second, and fourth one. Yes, one.
Okay, sir.
Yes, ma'am. Yes, ma'am. Yes. Okay,
Oh.
ma'am. Okay. Thank you.
Yeah.
So we have the distribution one also.
Yes, sir. We are yet to come.
Okay. Okay.
Am I running out of time? Okay. Yeah, I'm running out of time. No, distribution, I'll just say you what it is because we are not digging deep into it because EM algorithm itself takes a lot of time. I'll just say you what it is. Okay. So now I'll just complete this alone. So complete linkage. I want you people to answer. So I told you the first step, you're going to take the minimum distance. But when you're pairing it up, for single linkage, you went with the minimum distance. For complete linkage, you will go with the maximum distance. Now tell me what will be the values that I'll be substituting for 42 and 43. When I'm pairing 42 and 43, what will be the values?
Yes,
The
ma'am.
minimum of both.
Come again, ma'am.
The
Yes,
minimum
24,
value.
20, 17, 15, and 0.
For single linkage, we gave 24, 20, 17 and 15. Okay. Now I'm talking about complete linkage. Complete linkage goes with the maximum value. So what will be the values?
In this case,
25,
25, 21, 18,
Exactly.
16, and
So
1.
exactly. So here I'll be having 25. I'll be having 21 and
18,
18. Here I'll be having 16.
1.
Right? Yeah, 1 is what we have combined, right? At distance 1 we have
Yeah.
combined. So now this
Yeah,
will
with
be
the
my
27.
values. Now again 2 is
Yeah.
the minimum value. Now we are going to combine 25 with 27. So 25 with 27, when I write, what will be my values?
9, 5,
Yeah.
2.
5, 2, 2.
So I'll be going on with 9, 5.
5.
Fine. I'll be going on with 9 and 5.
Good.
So here
And
I
then
should go with
16.
15 or 17. Okay. So here I'm going with 17. Fine. So now what will happen after 25, 22, which is the minimum value?
Will be now 5, no? Or
4. I still have 4. Right? Previously, when we did single linkage, it was 3. But now my cluster is changing. Can you see the difference? for complete linkage, my cluster is changing at this point. So 4 will be my minimum value now. So I'll be combining 18 and 22. Am I clear? You people are not with me.
Yes, ma'am. No, yes, ma'am.
Alright.
It's okay.
So
Yeah.
for complete linkage, I'll be going with 4. So 4 is my minimum value. So I'll be combining 18 and 22. So here you can see that I have combined 25, 27 with 22. But when I'm going with the complete linkage, it will be 18 and 22. So when I'm combining 18 and 22, I'll be replacing these two with 7 and 24. Right? So here I'll be getting 7 and 24. So again, my minimum value will become as 7, right? And so I'll be combining these two groups. That is 1822 with 2527. I'll be combining. Hoping that you people are understanding me.
Yes,
Am I
ma'am.
clear? Okay.
Yes, ma'am.
Yes,
So
ma'am.
this is where the change will come when it is going to be a complete linkage. Now again, I'm going to discard here and I want you people to answer for average linkage. So again, the same problem. Say suppose 1 is my minimum distance. Now give me the values for 42, 43. What will be my values for 42, 43? So we are talking about average linkage.
Okay. 24.5.
Must be 24 plus 25 divided by 2.
Yes.
24.5,
49 divided by 2.
20.5. Yeah,
Yeah.
17.5.
Here again 20.5, 17.5, 15.5, it goes on. Fine. So again, I think 2 will be the same. So 2 will be retained. Then again, it goes on and on. Am I clear?
Yes, ma'am.
Okay. So we'll go. I'll first show how we had done for this single data. Okay. And that is 1D. Then I'll show you the 2D. You can see here the dendrogram is being formed. The distance calculation, which are the clusters that are being merged. Right. So this is my dendrogram. You can see that initially it was 42, 43 at distance 1, then 25, 22 at distance 2, fine. Then 25, 27 along with 22 at 3, and then it is combined with 18 at 4, and the final dendrogram at 15. Am I clear? This was the problem which we saw now. Say suppose I'm going with another data set. So you can see this has a larger data set. Dendrogram has been formed here each and every time. Distance calculation. I can speed up the process. All right. So this is how is the final cluster. So from different colors, it has been changed to single color. Somewhere there is an orange. I need to check. Okay. Am I clear?
Yes, ma'am.
So distribution based, I'm not going to take much time, don't worry. It is only one single slide. So it is basically the probabilistic based model. I'll just give you one small graph. So when we did k-means or DB scan or whatever it is, we had grouped the data points as three different or three distinct clusters, whereas GMM, that is Gaussian mixture model, it will be going on like a fuzzy. Fine. So you will be having this kind of overlap over here. Fine. That is why you can see here the likelihood. So probabilistic model, it is being told, and it basically works on the likelihood. Fine. So coming on with the last topic, do you want to go for a break and come back, or shall I finish dimensionality reduction?
Okay, ma'am.
Means you want me to continue, ma'am?
Yeah, we can take 15 minutes break and we can join after 15 minutes.
Okay.
We'll continue.
Okay.
Shall we have a break?
Yes, I am okay with it.
Yes, ma'am.
Okay.
Yes, ma'am.
Yeah, we'll join
So
by
7:16,
30
we
or
can
35.
come back by 7:30.
7:31. Oh.
Oh, 31. Okay.
Thank you.
Excuse me, the coordinator, ma'am. We are requesting you to kindly this provide this lecture materials, ma'am, at the end of the day itself, ma'am. If you
Yeah,
can,
today
please,
night,
ma'am.
today after the session, I will share all the videos.
Okay, okay. Thank you, ma'am. Thank you.
Thank you.
Ask this, ma'am, also. So to just the PPT as well as the screenshot of the Excel sheet also, ma'am.
Yeah, sure.
Okay, okay. Thank you, ma'am. Thank you.
Thank you.